Welcome to the first course in the Game Design and Development Specialization. You're about to start the exciting journey into game making. I'm Brian Wynn, the instructor of this course, and of the 5-course specialization that this course is part of. I'm a professor of games and interactive media at Michigan State University in the Department of Media and Information. I'm also an indie game and serious game developer. In this video, I'll set the stage for what we're doing in this course. This course and specialization are all about game making. How cool is that? But before we get ahead of ourselves, I'd like to start with a bit of a warning. Game playing and game development are not the same thing. That is, play is important in knowing good and bad about design, but game development is much more rigorous than play. It's comparable to watching movies versus movie production. Watching movies is enjoyable. Making movies is a lot of hard work. Just because you enjoy playing games does not necessarily mean you'll enjoy making them. Fortunately for many, like myself, they actually enjoy it more. But for some, after trying it out, they decide, hey, I just want to play games. And that's okay. This is part of the learning process. In either case, this specialization will help you determine if game making is your passion or not. This specialization will give a sampling of most of the aspects of game development, including design, engineering, art, production, quality assurance, and audio. We'll touch upon each of these things, but only scratch them at a surface level. This specialization is meant as an introduction, a first step. After this specialization, if you desire more, you can dive deeper into one or more of these disciplines. Let's talk about the game industry for a minute. As a trend over the last 50 years, the game industry has been expanding. Recent Newzoo statistics show the global game industry as a nearly $200 billion industry across multiple game platforms, including mobile, console, and PC games. There is also year-over-year growth across the world. Notice the size of the markets outside of North America. Game playing is truly a global passion. So there is growing opportunities in the game industry, but it's still a competitive marketplace. There are some parallels to Hollywood and the film industry here. There are a lot of people that have dreams of getting into the industry, but skill, experience, motivation, and personal connections are the best way to get in. Overall, like most things in life, it requires commitment to succeed. Commitment, like taking a course such as this. Fortunately, game development concepts apply beyond interactive entertainment to industries such as the serious games industry and the much larger interactive media or digital media industries. That is, the knowledge and skills you learn making games are applicable to many jobs today. Beyond the industries, there are many aspects of game development. You can also look at game platforms, distribution channels, and the various game makers. You may find yourself with some combination of interests across this table. For example, you might be primarily interested in working on AAA interactive entertainment games for consoles that are sold at retail by a major publisher. Or you may be interested in working on indie games for VR platforms that are distributed digitally by an independent development studio. We will touch on all of these in this specialization, but once again, only scratch the surface and lay a foundation for future exploration. Overall, many of you have different motivators to take this specialization. Some are taking it because you want a career in game development, or you're curious about game development and want to learn more, or you think it might be good fun and want to pursue game making as a hobby, or maybe you can use game making skills in other disciplines. With that said, I structured the specialization to service all these needs with a focus on those interested long-term in careers in the game industry. I teach both theory and practice in this specialization. A lot of the theory comes out in the conceptual video lectures. A lot of the practice comes out through the hands-on technical tutorials that you'll do and the projects that you'll make. One of the best ways to make games is by doing it. Therefore, we'll definitely be making games. In particular, in this first course, you'll make 2 projects. First, you'll be introduced to the Unity game engine and the editor by creating the Solar System project. Then, you'll create your first full-fledged game in the form of a 2D shooter game. In both projects, I'll guide you through the process, introducing concepts and then putting them into practice. And across this course, We'll also discuss the game design process, game engines, game development in Unity, and Unity programming concepts. I like the phrase, game development is hard fun. It takes a lot of work, but hopefully it's very rewarding work, and we're learning about and working on games, so it definitely should be fun. So, let's talk a little bit more about the sequencing of the overall specialization. As I said, the first course focuses on an introduction to the technical elements of game development, or actually building a game. And like I just mentioned, you'll go through two projects, the Solar System project to get you up and running with Unity, and the 2D shooter game. The second course builds on the foundation of development and adds in game design by talking about the design, play, and experience framework. You'll also take on your second game project in this course, in the form of a 2D platformer. The third course adds intermediate development techniques in Unity by working on a 3D shooter game, while we continue to discuss game design concepts. The fourth course rounds out your development skills by creating a 3D platformer game. We also explore how to generate and document your own game ideas while discussing the game industry and their impact on society. The specialization ends with a capstone project, where you will design and develop a game of your own design. So, we're off and running with Game Design and Development 1. Please pace yourself through the material. I've tried to put together a really solid foundation for you, and I'm certain you'll get a lot out of the course and the entire specialization if you stick with it. And remember to have fun along the way. I suggest jumping right into the next set of content now, and enjoy yourself in the course. In this lecture, I'll share a bit about myself and my background. My name is Brian Wynn, and I'm a professor in the Department of Media and Information and the director of the Games for Entertainment and Learning Lab at Michigan State University. I'm also a co-founder of Will Win Games. I was born in 1971, 1 year before Pong was released to the arcade. At the early age of 7, I can remember going to the pizza parlor with my family and seeing Space Invaders for the first time. I was hooked. I would beg my dad for quarters to play. This continued over the next few years as a flurry of arcade games came on the scene, from Asteroids to Pac-Man to Donkey Kong. These early games really helped shape my view of game design. When I was around 9 years old, my family got an Atari 2600. This was the first time I could play digital games at home. Of course, the games were not as good as the arcade equivalents, but rather than beg for quarters after each game over screen, I could play games for hours on end and really start to think about what made a good game a good game. 2 years later, we got an Apple II Plus computer. Rather than buy games for the computer, my dad bought me a book, something like How to Program Games in BASIC. I began to learn to program. I first copied the code directly from the book into the computer. Then I began to modify the code to change and expand the games. Eventually, I was able to write entire new games based on the techniques that I had learned. Of course, they were very primitive by today's standards, but it launched my love of creating interactive entertainment. This ultimately led me to pursue computer science as an undergraduate student at the University of Minnesota Duluth. This is where I really learned how to program properly. During the summer of my junior year, I interned at IBM. While I cherished my time there and learned a lot, ultimately I decided I did not want to work on traditional software projects. I really wanted to work on games. This led me to pursue graduate school. I ended up going to Michigan State University for graduate school, with a focus on computer science, artificial intelligence, and human-computer interaction. While this was the best decision I ever made, unfortunately at the time, there were no courses in game design and development. After all, this was the first half of the 1990s, and the universities had not yet developed any curriculum in this area. The closest course I could find was called Hypermedia Design. In this class, we used a multimedia authoring tool called Director to craft interactive media experiences. For the final project, we were tasked to create an autobiography, sort of an early version of a homepage or LinkedIn profile. Rather than a straightforward menu of information, I created an interactive game called The Case of the Salami Slicer, where you learned about me through role-playing as an investigative reporter trying to break the next big story. This course solidified my desire to create interactive experiences and games. After graduation in 1995, I worked for 10 years building interactive media projects for the Communication Technology Lab at Michigan State University. We created dozens of educational CD-ROMs and websites, many of which included games or game-like elements. In 2005, I founded the Games for Entertainment and Learning Lab at Michigan State University. The mission of the GEL Lab is to design innovative prototypes, techniques, and complete games for entertainment and learning, and to advance the state-of-the-art knowledge about games. I continue to direct the lab to this day. In my time at the lab, I've programmed, designed, and/or produced over 30 game projects. You can learn more about the GEL Lab at gel.msu.edu. In 2020, I helped start the company Will Win Games, with the goal of creating games that bring players together to have shared entertainment experiences. Plunder Panic is our first game, a swashbuckling up to 12-player action arcade game where two rival crews battle for supremacy on the high seas. If you love games like Super Smash Bros. Or Towerfall, you should check it out. Overall, I've got experience making games in both academic and commercial settings. My early experiences developing games and interactive media led me into teaching. In the fall of 2000, I taught the first ever Special Topics course in game development at MSU. The Special Topics course was very popular and was soon made into a regular course. This one course quickly grew to 2 courses. In the summer of 2005, the Department of Media and Information decided to go all in on games. We formulated a unique interdisciplinary program in game design and development. The program grew to be a top 10 ranked program in 2011 and continues its high rankings today. In 2020, we launched our full undergraduate major in games and interactive media, representing another major milestone in the MSU's game development program. My goal as a teacher is to motivate my students and create a structured learning environment that actively engages them in the subject matter. In that sense, I'm a guide, coach, and mentor, more than the proverbial sage on the stage. Making games is hard. Making good games is even harder. In order for my students to succeed, they need to build their technical and creative skills. To do this, I try to create authentic, real-world problems for my students to work on. This means that the students have to create games, and they end up creating a lot of games as they go through my courses. I really stress iterative development. That is, design, prototype, playtest, and refine. The more times you can go through the iterative loop, the more you will learn and the better your games will get. Of course, making games is not typically a one-person affair. Modern game development requires teams of individuals with complementary skill sets working together in harmony. For this reason, I also really stress soft skills in my classes, such as communication, collaboration, negotiation, ideation, time management, and leadership. For many of my students, creating games is a labor of love. My goal is to harness this passion, polish, refine, and nurture it, and push my students to advance not only in themselves, but also the art and science of making games. So that's a bit about me, my background, and some context around this course and the MSU Game Development Program. I look forward to learning and working with you across this course. In this lecture, I'll discuss the game design process. Let's start by talking about the uniqueness of digital games. The game designer Ernest Adams once said, "Games can make dreams real." This is the unique characteristic of interactive entertainment that sets it apart from other forms. Interactive entertainment can take you away to a wonderful place and there let you do an amazing thing. Books and movies can't do that. They can take you away to a wonderful place, but they can't let you do an amazing thing. Books and movies can create fantastic worlds and show them to you, but they can't let you be a part of them. Games create worlds, and they can let you live inside of them as well. Let's talk about how games are made. To do this, I'm going to use a construction analogy. That is, I'm going to relate building games to constructing a home. The first thing that you need to think about when you're building a home is who are you building it for? You'll build it very differently for a group of college students than for a small family with a second child on the way. The same concept applies to games. You need to know who you're making your game for. That is, you need to know who is your target audience. Beyond traditional demographics like age, gender, and culture with games, one of the most significant differences between players is the player style. Are they a core gamer or are they a casual gamer? Core gamers play for the exhilaration of beating the game. They'll tolerate frustration to get to the next level of the game, while a casual player plays for the sheer enjoyment. If the game becomes frustrating, they'll stop playing, put it down, and maybe find another game. When building a house, the location is very important. What neighborhoods are hot, which have comparable properties, what have additional location features like they're in town or they have a big backyard, they have a nice view. As they say in real estate, the three most important things are location, location, location. Our neighborhoods in game development is the game platform. Four of the most prominent platform categories are PC games, Windows and Macintosh, console games, most notable with Nintendo's latest platform or Microsoft's latest platform or Sony's latest platform, and mobile games, most dominated by Apple iOS and, of course, Android. The fourth category being web games. Each platform or each platform category reaches a different audience and has certain advantages and disadvantages. In terms of construction materials, homes are made of brick, concrete, steel, and wood. It's very important for the builder to understand the physical and aesthetic properties of these materials. Games ultimately are made up of digital code, ones and zeros, that control literally millions of switches within the computing device. In the early days of game development, we sometimes worked at this very low level to get the most out of the primitive hardware. But today, we usually don't work with computers at this level. So let's talk about the construction materials of games or game technology. Just like in construction, game technology is built from the ground up. So let's look at our game technology stack. So in construction, we talk about, starting with the earth. We dig a hole in the ground. Our earth in game technology is the hardware we're building upon. The next layer up, in construction would be we then pour our foundation that we build our house upon. Our foundation in game technology is our operating system. These two things together, our hardware and our operating system, make up our game platform. Moving up our stack here, we add the framing of our house on top of the foundation. The framing of our game technology is our game engine. So this provides things like our graphics rendering capability, our physics interactions, our networking, our ability to read input, and so on. And then we do our finishing work. Our finishing work in our game technology stack is basically everything that we bring in as our game development team. So our game-specific code, our graphical assets, our sound effects, and so on. However, from a design perspective, we often should conceptualize the game from the top down. That is, we start with thinking of the target audience. What graphics and sounds and scenarios and game mechanics would they find, most desirable? Then we come up with the design to, meet those needs of the target audience. And then we work out all those technical details, like what game engine should we use, what platform should we build upon, and so forth. Now let's discuss the role of the game designer in the game design process. First and foremost, the game designer must understand fun. To that end, as a designer, you must be able to answer these questions. What makes a game fun? Why do players play? Why are games engaging? What draws us in? So what does a game designer do? Well, they imagine, they define, they describe, they transmit, they implement, and they listen. We're going to talk about each of these in some amount of detail, starting with imagine. So where do ideas come from? They come from messing around. They come from looking at one thing and seeing something different. They come from asking why and why not, from not being satisfied with yesterday's discovery. Ideas come from other ideas, not from a vacuum. The famous French photographer Henri Cartier-Bresson once said, "There are no new ideas in the world, only different arrangements of things." So what are sources of good game ideas? Of course, you can get inspired by other media, from film, from television, from books. I mean, so many games out there were inspired by things like Star Wars, by, books like The Lord of the Rings, and so forth. You can also get great game ideas from life experiences, going out in the world and traveling, experiencing new cultures, meeting people, talking to people, doing things like playing sports, having new experiences, that sort of thing. Of course, you can also be inspired by education, looking at history, looking at art, humanities, even engineering. All of those things can be great inspirations for game ideas. And of course, you can also be inspired by other games, and not just digital games. If your focus is creating digital games, you might get a lot of inspiration from playing a board game, for example. Ernest Adams, the game designer, also said game ideas come from almost anywhere, but they don't just walk up and introduce themselves. Creativity is an active, not a passive process. And of course, game designers also need to define these ideas. So, what do they actually need to define? They need to define all the elements that make up the game. This is the design play experience framework that I came up. We'll be using this throughout this course. It decomposes the elements that make up a game. The framework defines the role of the designer on one side and the player on the other. So the designer designs the game that the player will ultimately experience. But in the middle is this sort of magic place where the designer and the player meet. So that is the actual dynamic play experience of the game. So below that top layer of design play experience, you can see these different elements that the designer must actually design, such as the storytelling in the game, or the gameplay, or the user experience. And these three things rest on the bed of technology. So the technology defines the user experience or limits it or enables it, as well as the gameplay and the storytelling. And there's a design aspect where the designer will design, for example, a story into the game. Then there's the middle area where that story evolves for the player. One player might go left, another player goes right. That's where the storytelling actually happens. And then there's the actual experience element that the player actually walks away with. So that's the actual player story. When I play the game, I'm going to walk away with a different story than when you play the game, as an example. So each of these elements, storytelling, gameplay, user experience, has a design, play, and experience aspect. We'll talk about this in more detail later. So the next thing that we need to do as a game designer is we need to be able to describe our game. So how do we describe the elements that we just talked about that make up our game? It's very important to do this in a conceptual way. This means being clear, concise, accurate, unambiguous, and above all, understandable. Often this is done in verbal communication as well as written form. Yes, to be a good game designer, I really think you need to be a good writer. You also need to describe these elements in a very functional way. That is, you need to be very explicit. You need to cover all of the conditions. If you think of a game mechanic, how is that game mechanic going to function throughout the game when all the different conditions are in effect? And you also need to describe them in an artistic sense. So you need to be able to, communicate these things through perhaps illustrations, storyboards, artistic renderings, and so forth. And that doesn't mean that you necessarily need to be a great artist yourself, but you need to be able to, work with an artist, pass your ideas on to an artist so they can then, create those elements that help describe your game to a larger team. And that leads us to the next element. The designer needs to be able to transmit that design of the game that they're describing. This is often done during meetings or via design documentation. We'll discuss both of these elements, team meetings and design documentation in more detail as we continue through the course. Game designers then must assist in the implementation of the game. Game designers are not just the idea person. I repeat this, that the notion that a game designer just sits back and comes up with great ideas and then there's a team that implements those great ideas, that is a myth.
The game designer is a very active member of the implementation team. Here are just some of the few things that they do. They hold that vision of the game, and the vision may not actually even come from them. It may come from somebody else. It may come from a mandate. They may be making a sequel to a game that already exists. So the vision may already exist. But they hold that vision, and they are the checker of that vision. So as the game is coming together, they make sure that the game is matching the vision that was set out for at the beginning. Game designers often are the best quality assurance people. They play test the game themselves, and of course they get play testers and observe those play tests and make sure, once again, that it's following that vision. Game designers often also need to prototype their ideas, so they need to be able to kind of get into a game engine. It might not be the actual engine that the end game is being made, but they need to be able to have a tool that they can use to prototype the ideas that they're coming up with to help communicate that to the larger team. This could be in the form of a physical prototype, we'll talk about that more later, or a digital prototype. Game designers often are the ones that are actually putting together the levels of the game, so working with programmers that are implementing the game mechanics or the gameplay, and working with artists that are creating all the art assets, and then the game designer is the one that assembles those to actually create the levels. Game designers also are often involved in the user interface design of a game. It's one of the roles that game designers often take. And sometimes game designers also maybe manage or lead the team. Particularly on a smaller team project, a game designer might be wearing multiple hats, and one of those hats might be team lead. Across all of these tasks, a game designer must be a good listener. Who do they listen to? Well, first and foremost, they need to listen to themselves. They need to, have sort of an inner sense of their design and kind of trust their gut as the game is evolving and as they are designing it, as they are seeing how it progresses. Of course, they also need to listen to their players, that target audience that we talked about, the play testers. So they need to listen to the feedback that they're getting, and maybe the design isn't accomplishing what they think it would accomplish. Back to that design play experience framework that we talked about. If the experience that the players are actually having is not the experience that the designer thinks they should be having, then they need to go back and modify that design. Of course, they also need to listen to their team. Your team is one of the most important aspects. We'll talk about that a little bit more later. But the team is also sharing in the design. So being a game designer doesn't just mean that, once again, that you're coming up with all the ideas. You're listening to your team, because a lot of times a programmer may have the best idea, or an artist may have the best idea that can funnel into the overall design of the game. And the game designer also needs to listen to the industry. What are the trends? What is popular? What is emerging? What is fading? They need to understand the world out there. How is the world changing? What is the world, opening up to, and that sort of thing. These are all important things that the game designer needs to be able to listen to. Now let's discuss the game development team. First, you must understand that games are made by people for people. The success of a game comes from the people involved on the team and the efforts they put into the game. We'll discuss the importance of the team in great detail at various stages across the course. To start this discussion, let's relate the team back to our construction analogy. Games, like building construction, usually employs many different roles or jobs to get the project done. The game designer is just one of those roles. You can view a game designer like an architect on a construction project. The producers are the folks that manage the project, including both the people on the team and the resources. The programmers are like the tradespeople, the masons, the carpenters, the electricians, the plumbers. They're the ones that build the core structure of the game. And the artists and sound designers can be analogous to the interior designers, the painters, the landscapers that make the game aesthetically pleasing to the target audience. The make of the team will vary largely based on the size and scope of the project, just like it is in construction. For example, if you're building a shed, you probably only need a small number of people. But if you're building a skyscraper, you need hundreds, if not thousands of people. The same can be found in game development. So a small size team is one, of course, that's going to take on a smaller scoped project. It's maybe 1 to 5 people, where each person has to wear multiple hats and kind of have a broad skill set to be able to take on those different things. So they have a broad responsibility and less management, because there's less people, less lines of communication. So the typical roles that we see in a small team are that of the designer, the programmer, and the artist. You can throw sound design in here as well. These are kind of the core skill sets that are needed on any game project. When we move up to a slightly larger team or a medium-sized team, 4 to 25 people, this is where we start to have the need for people to manage the team. So we add producers that manage schedules, manage budgets, probably most importantly, manage communication across the different stakeholders. And of course, they take on various odd jobs along the way. As team size grow, these odd jobs pop up. The disciplines themselves, we may need to become more specialized as the size of the project grows. For example, in the programming bucket, we may have gameplay programmers, we may have graphic programmers, we may have networking programmers, rather than just a sole programmer that's taking on all those roles. Because on a larger project, a larger scope project, we need to divide and conquer, and we need maybe special expertise in certain areas. And the same can be said across design and art as well. With a larger sized team, a larger sized project, 25 plus, I would say, we need even more people to manage the team. So we may, have leaders or managers in each of these areas, like a lead designer, a lead programmer, a lead artist. We often add in-between roles as well to bridge across those disciplines. So for example, we have level designers that bridge across design and art. We have technical artists that bridge across art and programming. And we have scripters or maybe mission planners that bridge across design and programming. Some of the names of these in-between positions vary across the industry. For example, one company may view a level designer as a bridge across design and programming rather than the design and art, or perhaps they bridge across all three. These in-between positions, currently in the game industry, we're seeing a vast need for these kind of people that can wear multiple hats and kind of understand the unique aspects of each discipline and then can hone that into the game that is actually being built. Let's conclude our discussion on the game design process with a look at costs and limitations in design. Just like costs vary wildly in constructions, once again, from building a shed to building, a skyscraper or a mansion, the same is true for game development. This chart, which comes from the Games for Impact group, just shows average costs across different platforms. So you can get, an idea that, making a web-based game or a small mobile game is probably going to take a lot less money than creating a AAA, game for a modern console. Now, of course, you could have, a game for a console cost much less, but it probably wouldn't be of the AAA caliber. And of course, you could have a mobile game cost much more, to really amp up the scope and the quality of that game. So what drives cost? Different projects have different elements that drive the costs, but the typical line items on a budget are typically labor. Remember, games are made by people, and labor often is the biggest driver of cost on any game project. Like we said, for a AAA game, you may employ hundreds, if not thousands of people. And of course, the burn rate, the amount of money it takes to pay all those people on a monthly basis grows very quickly. Another driver of cost is technology. To make games, we often need a collection of hardware and software technology. We need the devices, we need the dev kits. We need, things to support that technology, perhaps servers, backups, motion capture, VR headsets, things like that. And all of those things, add up, of course. Depending on what we're making, there may be licensing costs for the intellectual property, based on maybe technology or the game engine that we're using, or it could be licensing of creative content. Maybe we're making a game based on some creative IP. Of course, there's also distribution costs. This used to be the cost to package up the game and ship it across the country and get it on the shelves. Currently today we mostly do digital distribution. So the distribution cost often is the cost that we're paying for the distribution channel, be it something like Steam or the App Store. Often there's something like a 70-30 split where the distribution channel is taking 30% of the cost. So if you sell a game for $10, they're taking $3 and you're getting $7 back. And then, of course, there's also the marketing costs. So how do we get people to know about your game and convert them into a customer of your game? Often, your marketing costs may be just as big as the development costs of the game. And, of course, there's also other overhead, other expenses in running a company. There may be rent, there may be utilities, there may be taxes, legal expenses, accounting expenses, supplies, furniture, business travel, et cetera, et cetera. All these things, of course, add up. And that's where limitations come in design. When we're talking about building games, we're always working with limitations. And one of the biggest limitations is money, back to what we just talked about with what drives cost. You never have enough money to do what you want to do often. So, budget is one of our biggest design limitations. Another limitation, of course, is technology itself. Technology is a great enabler that allows us to do great and wonderful things that we couldn't do without the technology, but it also can be a limitation. So, what's possible on a given game platform that we're building for? What's possible in a given game engine, to realize the vision of our game? All those things may limit us in some ways. Of course, time is always a limitation. It takes time to build games. I'm sure you've heard the famous quote that time is more valuable than money. You can always get more money, but you can never get more time. That definitely is a true statement when it comes to game development. Another limitation in design is expertise. What is the expertise of the team? What is the skill level of the team? It's very difficult to make a game, and it takes knowledge and experience to succeed. You build your skills over time, of course. Any new project I take on, I try to take baby steps forward to expand my skills, but I realize that I'll not be able to take giant leaps on many fronts at the same time. Otherwise, I'll likely stumble. The same concept can be applied across the team. So, understanding where your team is at and what is possible with your team at that given moment is an important realization. The game designer Richard Roos III said that design is about understanding limitations and turning those limitations into advantages through knowledge and creativity. I always like this quote. It is a mindset that allows you to turn your deficits into assets as you design games. In this lecture, I'm going to discuss game engines. What are they, why we use them, and then discuss the Unity game engine, which is the engine we'll be using throughout this course. Let's start by talking about what features all game engines need from a software functionality perspective. All games need the ability to load and display visual assets, load and play back sound effects, receive player input, maybe it's keyboard and mouse, maybe it's a controller, maybe it's a camera and microphone. All games need some sort of game logic, which is essentially the mechanics or rules of the game translated into code. And of course, all games need the unique game assets. These are the visuals and sounds and so forth that make the game look and sound unique. So how do we build this? One technique is to build everything from scratch. That starts with building all the core game functionality, all those core software systems. So for example, we have a JPEG image that we want to display. We would have to write code to load that image into memory, decompress it, and then render it to the screen. We would have to do the same thing for audio, player input, and all those things we just talked about. Once we get all that done, then we could actually focus on the game that we want to build. Those game specific features, the game logic, the game assets that makes our game unique. Building everything from scratch certainly used to be the norm back in the early days of game development. Today, this approach is no longer the norm. Today, it's only done in rare cases. The second option is to use a game engine. So let's talk a little bit about what a game engine is. Game engines really provide that core game functionality that we talked about. So the graphics rendering, the support for different graphics file formats, the playback of audio, reading player input, physics simulations, etc., etc. All those things that you use in most games would typically be built into a game engine. And then when you're creating your game, you're building on top of that engine. This is very similar to the concept of an automobile, where an auto manufacturer creates an engine and then they build multiple different types of cars that use that same engine. So what the game engine allows us to do is it allows us to focus on the unique elements of our game without having to worry about this core game functionality that really transcends many, many games. This represents the technology stack that a game typically runs on. The game engine really sits between the game platform, that is the hardware and operating system, and our game-specific code. So the game engine is your game interface to the operating system and hardware. And in fact, often a game engine is designed so that your game-specific content can move easily from one game platform to another. So the engine will allow you to move quickly from, let's say, Windows to Macintosh, from iOS to Android, and even perhaps from a PC to a game console. So one thing that typically comes along with a game engine is a game editor. These are tools that make assembling the game more intuitive and more visual, so we don't have to do everything at the code level. It also allows us to integrate game designers and artists and others into the game development process more easily. Most engines have some sort of editor. Here are some of the most popular game engines today and their respective editors. We'll be talking about Unity in detail in this course. It is both a game engine and a game editor. So what is Unity? Unity is one of the most common game engines and game editors used in the game industry, in education, and by hobbyist game makers today. It is the engine we'll be using throughout this course. So why is Unity so popular, and why did we pick it for this course? One of the things I really like about Unity is it's not game genre specific. What I mean by this is that you're not locked into making a certain type of game. You don't have to make just role-playing games or just 2D platformer games. You could make 2D games, you could make 3D games, you could make games of all different types of mechanics and all different types of genres. It's a very feature-rich game engine. It has very good graphics rendering, lighting, physics, particle systems, a sound engine, and so on. All those features that you want to have in your game, but you don't want to have to write from scratch yourself. And once you learn to use those features on one game project, you can quickly move to a new game title and leverage the knowledge that you've built. Unity is fairly easy to learn from a getting started point of view, but it has deep features. So you can get up to speed quickly, but it has enough depth to grow with you. Unity has a really great asset pipeline. Basically, the pipeline is how you get your graphic assets, your sound assets, and so forth into the engine. Unity makes that very painless in most cases. We'll talk more about this later. Unity also comes with great documentation. This is very important when you're learning something new. There's also a great community surrounding the engine, posting questions and answers on the web, and that makes things really handy when you do run into a problem or you're exploring a new feature. Just a few more things. Unity supports iterative game development. Iterative development is one of the primary ways that we make games, or at least good games, today. For example, with Unity, you don't have a long compile time to get your game up and ready to test. We'll talk more about iterative development throughout this course. It's a relatively efficient engine, so you can make high-performance games with fast frame rates. And you can also build your game to many different platforms. Like I said, the game engine often is the bridge to various game platforms. Unity supports building games to Mac, Windows, Linux, WebGL, iOS, Android, and many of the modern game consoles. Further, it supports things like virtual reality and AR headsets. So the knowledge that you build in Unity can be applied to various game platforms. And of course, the game that you build could be moved from one platform to another, in most cases with minimal redevelopment or minimal changes along the way, which is a big win. It's a relatively inexpensive engine. There's a free version of Unity that we'll be using throughout this course that's available to students and hobbyists and indie developers. There's also a professional version of Unity that does have a cost, but it's still relatively inexpensive to use compared to some other engines. Since Unity is so pervasive today, employers are seeking people with Unity skills. So the skills that you learn throughout this course applies directly to jobs that you might be seeking, which is great. So it's not just a toy. It's not just a learning tool. It's actually a tool that you can use commercially. The other nice thing is that if you do end up using a different engine down the road, the techniques that you learn in Unity apply to those other engines. Of course, there are other tools that you'll need along the way when developing a game. Unity, like most game engines and editors, does not do everything. You'll use other tools to support Unity. So for example, you'll need a script editor for editing your code. Unity comes with Microsoft's Visual Studio for script editing, but you could really use any script editor that you want. Further, Unity doesn't have an image editor. You'll use other tools like Photoshop and Illustrator and so forth to create 2D visuals, and 3D tools like Maya, 3ds Max, or Blender to create 3D content, and then bring them into Unity for use in your game. The same is true related to the use of sound editors to create sound effects and music. We'll talk more about these types of tools later in the course. It's time to build our first project in Unity. For this project, we're going to make a primitive model of our solar system. While the resulting project is not technically a game, this project will showcase the basic workflow in making games and get you familiar with the Unity editor while building your game development knowledge and skills. You will apply the knowledge and skills that you gain in this project to all future projects. The concepts we'll learn include creating game objects, understanding 3D space, including vectors and transformations, creating and modifying materials, attaching behaviors to make your game objects move and react to the player, and the basics of lighting your 3D environments. We'll also discuss how to add audio to your games, how to work with cameras, and how to build and test your games, as well as how to save and prepare your project for submission as an assignment. You can view these lesson videos as a tutorial. During the lessons, do what works best for you to learn. You can follow along with the video as I go, or you can watch a bit of the video, then pause it, try to reproduce what I did, and then continue. Or you can watch the entire video, then reproduce what I did, and rewatch any parts of the video that you have trouble with. Or of course, you could do some combination of the above. Once again, do what works best for you. I will be covering many concepts and practical skills as we go. Try to not just replicate what I'm doing, but really try to understand why I'm doing it. Learn the process, the terminology, and the concepts. That way, you will truly build your knowledge and skills as a result of doing the project, not just have rote learning. And lastly, in addition to watching the videos, also make sure to read the assignment. You will need to use both the videos and the assignment write-up to complete the project. I encourage you to read the assignment now before we dive into the videos if you've not done so already. Then read it again at the end of the videos to make sure you finish up the project correctly. Okay, let's get started with the project. In this video, we'll walk through the process of setting up your workstation with Unity. Our objectives will be to download the Unity Hub, set up your Unity account, and install the Unity editor so we're ready to start using Unity to develop games. Let's get started.
All right, so the first thing that we're going to do is open up our web browser and direct it to unity.com. I've got the website up here. This is the home page for Unity. We'll use this site from time to time to access various resources and get in touch with the Unity community. They have some great learning tutorials and so forth. And we'll talk more about these later. But for now, we're going to download Unity. So at the top right, there is a Get Started option in blue. I'm going to go ahead and pick that. This brings us to a page that talks about how to get Unity and the different Unity plans and costs. Most of the versions of Unity are essentially the same in terms of the software, but there is a difference in terms of the cost and what additional services come with the license. In this course, you want to select the Individual tab, and this will show the Student and Personal edition of Unity. Both are free, and both are more than sufficient for learning and developing games as a student, hobbyist, or indie developer. The student version requires a bit of additional verification to prove that you're a student. You may want to go through this at some point, but for now and for purposes of example, I'll go ahead and get the Personal edition. So let me go ahead and click Get Started under Personal. And the web page that comes up prompts me to download the Unity Hub. At the top, it's asking me to download the beta version. If you scroll down here, you can see, there's the Unity Hub version 3 beta here. I'm going to go ahead and download the non-beta version of the software just so we're on a stable version. Now, of course, this is at time of recording. By the time you watch this in the future, Unity Hub version 3 may be out. But let me go ahead and download the Windows version of the non-beta Unity Hub. If you're on a Mac, of course, download the Mac version. So let me go ahead and click this and go through the process of installing Unity Hub. I'm going to go ahead and open that now. This is the setup for Unity Hub. And I'm going to say, yes, I want to allow it to modify my device because it's installing the software. I'm going to agree to the license agreement, and I can specify where it's going to install it on my device, on my hard drive. I'm just going to go with the default here and click Install. And while it's doing this, I'm going to minimize my browser window in the background, and the installation is complete. You can see it installed the hub as a shortcut on my desktop here. And when I click Finish, if you leave this as checked, it's going to go ahead and launch the Unity Hub. Now, when the Unity Hub first comes up, you'll see a message where it says you have no valid license. And it's asking me to click the Manage License button. Let me go ahead and do that. And then it says you need to be logged in to manage your license. Now, to use Unity and Unity Hub, you need to have a Unity ID. So there is a login button right here or up at the top, this little icon that looks kind of like a silhouette of a person. You can also click that and click Sign In. And this will prompt me to log in with my Unity ID, and if you don't have a Unity ID yet, which I suspect most of you don't, you can go ahead and click Create One. And this will bring up a form where you fill in your email and password and so forth. Just go ahead and follow that process. It doesn't cost any money to create a Unity ID, but you will need one for purposes of using Unity. So go through that process. Of course, I've already got a Unity ID, so I'm going to go ahead and log in with my ID. Okay, the next thing that you'll need to do is activate a new license. So let me go ahead and click on the Activate New License button. It's going to ask what type of license you want. You'll want a Unity personal license, and then you have to specify that you qualify for a personal license. So either your company or organization earns less than $100,000 a year, or you're not using Unity in a professional capacity. So as a student, I would probably pick I don't use Unity in a professional capacity. I'm going to actually pick the top option because I do use it in a professional capacity. And go ahead and click Done. This should give you a license for Unity, which will show up here under the license option. And once you have that, you should be able to install Unity. So let me back out of the preferences and go to the Installs section. So you can see here under Installs, it says No Unity Version. For this course, I want to make sure everyone uses the same version of Unity so you'll be in sync with my lessons and with each other. Check the course website for what version of Unity we're currently using in the course. For purposes of the example in this video, I'm going to go ahead and click Add, and you'll see that there is a recommended release of Unity specified here, and then there's additional official releases. And you can see Unity kind of comes out on a yearly pattern. So there's a 2022 version, a 2020 version, a 2019, 2018, and so forth. Now the LTS means long-term support version, which basically means it is a solid piece of software that they're supporting over a period of time. You can view it as kind of the official release, where the non-LTS version is one that's still sort of in development. It's kind of like an enhanced beta, if you will. So at the time of this recording, you can see there is not a long-term support version of Unity 2021 yet available. I want to make sure that we're working on a solid version of Unity. So we're going to use Unity 2020 long-term support in this class. Now, the version that shows for me is Unity 2020.3.25. At the time that you're actually doing this version may change because Unity actually comes out with new versions on an almost bi-weekly basis. If you ever want to download a different version than what's shown here in the Add Unity version window, you can click this Download Archive link here, and this will bring up the web browser to the Download Archive section of their website, and you can see that there are tabs for each version of Unity all the way back to Unity 3. And then they, after Unity 5, they switched to this sort of yearly pattern. So there's a 2017, a 2018, 2019, 2020. And if I go on 2020, you can see there's all the different versions of Unity 2020, over time and when it was released and so forth. So if I would want to download a previous version of Unity or one that's not specified there in the Unity Hub, I can come here and then click the Unity Hub button here, and that will start the process of downloading that version of Unity. Now, the reason you would want to download a different version of Unity is, for example, if you built a project today and then in 5 years you came back and you're on a new computer, but you wanted to open up your old project, you may want to download the version of Unity that you built that project upon, because when the software gets updated, there's new features and maybe old things break and so forth. So anyways, that's the Unity Download Archive. We're not going to actually use that today, so I'm going to go ahead and just minimize that, but I did want to show that. So back here in the Unity Hub under Add Unity Version, I'm going to select the latest version of Unity 2020. So for you, it may be here under Recommended Release, or it may be down under Official Release. So Unity 2020 LTS. Let me select that and click Next. Then it's going to ask what modules I want to include in my install of Unity. So you definitely want to check the Microsoft Visual Studio option. That is your editor for editing code, editing scripts. If you're a programmer already and have Visual Studio installed, maybe the full version of Visual Studio, you could uncheck that if it's checked. But this is the community version of Visual Studio, available for both Windows and Mac. It's the free version of Visual Studio from Microsoft. Now, the other modules that you install are what platforms you want to be able to build for out of Unity. What platforms you want to target. So you can see there's the mobile platforms, Android, iOS. There's PC platforms like Linux, Mac, and Windows. There's also WebGL, which is a web platform. So what you want to check is what I have checked. So you want to check the Mac build support, WebGL build support, and Windows build support. Those are the three platforms that we'll be building to in this class. Now, if in the future you want to build for mobile or something like that, you could always add those modules later. But we'll skip that for now because it does take up hard drive space to install them, and it takes longer to download and actually do the install. The last thing down here is documentation. I do recommend checking that and downloading the documentation so it's local on your hard drive. Of course, if you've got limited space, you could uncheck that and you could just access it off the web. There's also language packs if you wanted to grab one. I'm not going to check any of the language packs. And let me go ahead and click next. I have to agree to the licensing agreement for Visual Studio and then click done. And this will ask me if I want to actually install it. I'm going to say yes. And then it's going to go through the process of installing that version of Unity for me. Now, this process might take quite a bit of time depending on the speed of your internet connection and the speed of your computer to actually download all the files and extract them and run the install. So I'm going to go ahead and fast forward my video here until my installation is complete. Okay, my Unity Hub is now installed. Using Unity Hub, you can actually have multiple versions of Unity installed and manage them from within the hub. For example, I can click the Add button to add another version of Unity, or I can click the Locate button to locate a version of Unity that's already installed on my drive, but not yet added to the Unity Hub. Why would you want to have multiple versions of Unity, you might ask? If you have a project that is started in one version of Unity, you may not want to update it to a newer version of Unity, as doing so may break things that you'll need to fix. Therefore, for learning purposes in this course, I recommend sticking with the version of Unity that I specified for this course's projects. If you start a project on your own at some point, you may want to install a different, perhaps newer versions of Unity. From the Unity Hub, you can access all the versions of Unity that you've got installed on your hard drive. Okay, I now have Unity installed, and I'm ready to start developing games.